Hello everyone, I'm Arun Prohit. Welcome you all in this short lecture series. Today we will cover the second part of basics of air conditioning. In the part 1, you have learned the basic terms which are used in the study of air conditioning systems, covering dry bulb temperature, dew point temperature, adiabatic saturation process, wet bulb temperature, and you also learned that how 1 ton cooling capacity is defined. Today we will take up the second part, and after completing this lecture you should be able to understand the functions of an air conditioning system. You must also understand that how human comfort and air conditioning are related. You will also learn what are the different types of AC systems which are usually used in households as well as in industries. Then you will be learning the working of window AC, packaged AC system and central AC system. Friends, now let us learn different functions of an air conditioning system. An air conditioning system is used to heat or cool, humidify or dehumidify, clean and deodorize the air. The air which is there circulating all around us. You know, when we have air being very cold, then the temperature of our body, we feel some cold environment, and in those situations we need to get some hot air to get a normal temperature which gives us a comfort feeling. So basically in countries which are cold, the heating and humidification is required for conditioning the air, and when situations are such that the temperature of air is very high, then an AC system is used to cool it down, or it is required to dehumidify when we have large amount of moisture in the air. So an AC system is expected to carry out all these functions like heating, cooling, humidification, dehumidification. So basically an AC system conditions the air. Broadly, this field of study is known as HVAC, that is heating, ventilating and air conditioning. Human comfort and air conditioning. Friends, human comfort is strongly related with the dry bulb temperature of air around us. It is strongly related with the relative humidity of the air and the flow velocity of air around our body. So air conditioning system is required to control these three factors, like dry bulb temperature, it should maintain around 25 degrees Celsius, it should maintain the relative humidity also, and it is also required to maintain airflow. So you will find that in air conditioning system, by means of cooling arrangement, it controls the temperature, and by removing or adding the water vapor, it will control the relative humidity, and by means of some blower or some arrangement, it creates airflow in the air so as to give us a comfortable feeling. In summers, friends, we see that the temperature around us is very high, and since our body maintains its temperature, so the excess heat it needs to reject to the environment. Since the environment is already at high temperature, so it is difficult for us to reject the heat. Friends, do you know that our body reject heat in two ways? By perspiration, we reject latent heat, and by decreasing its temperature, we reject sensible heat. So the air conditioning system needs to provide an environment around our body so that it can reject the latent and sensible heat and feel comfortable. And the opposite will happen in winter's day, when our body temperature it is already around it is at constant level, but since the atmospheric temperature is at low temperature, so our body will start rejecting heat, and so we will feel somewhat uncomfortable, and we feel chilling effect on our body. So feel comfortable, we require to have air temperature to be increased, and may it contain less amount of moisture, so it is also required to increase its humidity, and that arrangement is also carried out by an air conditioning system. Now let us see what are the different types of air conditioning system which are used for this purpose. Many of them are well known to you, like window air conditioner, split air conditioner, and apart from these two, we also have packaged air conditioner system and central air conditioning system. First two, window and split air conditioners, are used for small applications, whereas for heavy loads we use central air conditioning. Friends, in this slide you see a window air conditioner. You see the compartment of a window air conditioner is divided by a partition. This partition create two different spaces. One space is kept inside the room, which is to be air conditioned, and the other part of this compartment is kept out of the room. The space which is kept inside the room is containing blower, adjustable lowers, control panel, front grill, a thermostat sensor is also there. We have filter which is adjusted over here on the evaporator coil, and on the outer part of this compartment we see there is a fan used to blow air over the condenser coils. You see condenser coils, and you know that in a condenser, since heat is rejected, so to provide air motion we use this fan. In this compartment we also have a compressor. And friends, you already have learned that in any refrigeration or air conditioning system, most of the time we use vapor compression cycle, and a vapor compression cycle is having main four components. And the first component, which is here in the form of a compressor used for compressing the refrigerant. Then from the compressor you have a condenser coil where the refrigerant is taken here to get cooled, and from a condenser we have a capillary tube which is not visible over here, but this capillary tube is there to get expansion of the refrigerant. After the expansion, since the refrigerant becomes so much cold, becomes so much at low temperature, that you will take it to evaporator coil. You can see it here, and from this evaporator coil the refrigerant is taken to the compressor. So basically you can notice all of the main components which are there in a window conditioner, air conditioner. To explain the working of a window air conditioner, just see the top view of a window AC. This is the top view, and in the top view you can notice this partition, and this part is kept inside the room, and you can see the arrows are showing the direction for the warm room air. So room air is taken inside this compartment, because this blower will, when it start rotating, it will create some vacuum over here, and since inside the room the pressure is normal atmospheric pressure, and here in the front of this blower the pressure is low, so there will be flow of warm room air inside this compartment. And since we have finned surface in the path of this warm room air, and we call this finned arrangement as evaporator. So there are coils as well as fins. So the warm room air, when come into contact with evaporator coils, it will get cooled, and an excess amount of humidity, that is moisture, is also get settled in form of fine droplets, so it become liquid water, and the air get cooled and channelized, you can see here, and from this channel it come back into the room, so you will get cooled room air here. So this is what we see, that how warm room air was converted into cooled room air in this compartment. And we have another outer compartment where you can see a compressor, a fan, and a motor. This motor is rotating this fan, and from here outside air can come into this compartment. So when we start an AC, what will happen? The compressor start working, and the high temperature refrigerant will enter into the condenser coil. Because the refrigerant is at high temperature, so the outside air, when blows because of the motion of this fan, will flow over the condenser surface, and because of this motion of the outside air, since the refrigerant is even at higher temperature than the temperature of outside air, so because of temperature difference, the refrigerant inside the condenser will get cooled, and we will have this air to be discharged, and it is at comparatively higher temperature. And you can see everything is happening over here. So this arrangement will give us condensation of the refrigerant in the condenser. Here you see a block diagram of window AC, and you already know that how a vapor compression cycle works, and all the elements are shown here by the simple blocks. And you already know that this red line shows the hot part of the cycle, and this blue part shows the colder part of the cycle, and this colder part is there inside the room, and this hot part is there outside the room. And you can see that how warm air is coming out of the condenser, and how we use this fan to get ambient air flow over the condenser surface. And we also see that evaporator coils are here, from which we get cold air channelized back into the room, and thus we get conditioned air. And you can see the droplets, water droplets over here, which is because of the removal of excess moisture from the room air, so that relative humidity can be kept around 50%. And you know that this 50% RH will give us comfort feeling. I hope you understood that how a window air conditioner works. Applications of window and split AC system. Friends, let me first tell you that split AC system and window AC system are basically same. The difference is there because of the separation of the two compartments, which you have noticed in case of window AC. The inside compartment of window AC is there in form of inner unit in split AC, and the outer compartment of window AC is in the form of outer unit for split AC. Friends, you certainly have seen that in case of split AC, we have outer unit where a compressor, a condenser is installed at roof or at some distant place from the place where we want to get the conditioning. And the room where we want to get conditioning, we install the inner part of the system, where we only have the part where we have evaporator coils, so that air can be flown over the evaporator coils and can get conditioned. So basically window and split AC systems are same. So one more thing, let me tell you that when cooling capacity required by us is up to 5 tons, we can go for window or split AC system. When the requirement is more than 5 tons, we will go for packaged AC system. Let me tell you that a packaged AC system contains all the important components of the air conditioners. They are enclosed in a single casing like a window AC, but their capacities are comparatively larger. So main components again are compressor, cooling coil, air handling unit and the air filter. Friends, packaged AC system are same as window or split AC system, but the difference is that they are having larger capacity, and that's why these systems are having two arrangement. They may have water cooled condenser or they may have air cooled condenser. Friends, we have seen in case of window AC, the arrangement was having air cooling for the condenser coil. So alternatively, we may also have water cooled condenser, and again we can also have air cooled condenser. Friends, in this slide you see a window air conditioner. You see the compartment of a window air conditioner is divided by a partition. This partition create two different spaces. One space is kept inside the room, which is to be air conditioned, and the other part of this compartment is kept out of the room. The space which is kept inside the room is containing blower, adjustable lowers, control panel, front grill, a thermostat sensor is also there. We have filter which is adjusted over here on the evaporator coil, and on the outer part of this compartment we see that, friends, we have another system which is more involved and more complicated, and it is your central AC system. Central AC system includes water cooled large compressor. Remember, it has the largest capacity. This type of system is used when the cooling requirement is more than 20 tons. So since the cooling requirement is high, we need to go for large compressor, and the large compressor might be this kind, that is multiple cylinder reciprocating type. Perhaps you have seen a car engine where we use multiple cylinders. So similar arrangement is also used for designing a compressor with large capacity, with large compression capacity. And since these compressors do a large job of compression, so they are water cooled. Now these compressors also have a condenser in series. Then we have thermostatic expansion valve, and obviously thereafter we have evaporator. Since we are using a vapor compression cycle, so same four components are being used in central AC system also. A small air conditioning system uses capillary tube for expansion of refrigerant, but in case of central AC system we use thermostatic expansion valve. And why we do so? Because a thermostatic expansion valve is a device that can be controlled more effectively as compared to capillary tube. And friends, in central AC system, the conditioned air flows through the ducts to all the rooms and halls or other spaces where we need to have air conditioning. Applications of central AC system. Central AC systems are used when the cooling capacity requirement is more than 20 tons. Dear students, central AC system become more efficient when we have the cooling capacity requirement to be more than 20 tons. So instead of using large number of window or split AC systems for cooling, for getting the cooling more than 20 tons, it is more economical to go for central AC system. In following cases, it is required to cool large buildings, hotels, theaters, airports, shopping malls. So friends, whenever you visit such places, so you can just understand that the kind of cooling you are feeling there is because of this central AC system.